electric potential is defined as a work done per unit charge on a positive touch charge when it's moved from infinity to a point in the field. So for example, in this case, if you look at the negative charge, if you want to move a positive charge from infinity where V is equal to 0, R equals infinity, if you want to move this to this point in the field here, it will take minus 40 joules per coulomb, and that's because it's a negative charge, so a positive charge will be attracted towards it. So that actually means energy is released. While in the case of the positive charge over here, if I want to move a positive charge of 1 coulomb all the way from infinity to this point, you would have to do work because you're moving a positive charge closer to another positive charge, so there will be repulsion. We can calculate the energy transfer that takes place when you move charged particles between 2 points. For example, from X to Z. The difference there is 80 minus 40, which is going to be 40 joules per coulomb, times that by the charge you're moving, which is 5, that gives me 200 joules. And because I'm moving a positive charge further away from a negative charge, we have to overcome that attraction. So we'll have to actually do some work. We'll need to push it away. Okay, to move a charged particle from infinity, so R equals infinity, V equals 0, to point Z, how much would be required? So the difference between V equals 0 and V equals 60 is 60. So 60 times 2.5 gives me 150 joules. Now if I'm moving a negative charge closer to a negative charge, I'd have to push it there, I'd have to do some work. Okay, to move a charge particle from C to B, we'll move the difference between C to B is 20 joules, 60 minus 40 joules per coulomb, times that by 1.5 gives us 30 joules. Now we're moving a negative charge closer towards a positive charge. So in this case, actually, electric potential energy will be released, and it will be released as kinetic energy. Actually, the negative charge would move towards the positive charge. Its kinetic energy increasing. To move a charged particle from minus 40 coulombs from A, for it to escape the field from A, so completely escape it and go to V equals 0 at R equals infinity. The difference between V equals 0 and 80 is 80 joules per coulomb. Multiply that by 4 coulombs, 320 joules. So we're moving a negative charge from here, which is being attracted towards a positive charge. So to move all the way to infinity, we will have to do some work. We'll have to push it there, so it's going to be work done.